Swayam Prabha. Digital India. Educated India.
CQL Cassandra Query Language. Preface. Content of this lecture. In this lecture we will discuss CQL, that is Cassandra Query Language, its mapping to Cassandra's internal data structure. All these internal details we are going to see in this part of the lecture. What problem does the CQL is going to solve? To understand this, let us first see the awesomeness that is the Cassandra. Cassandra is a distributed columnar data store that we have seen in the previous discussion. Here in Cassandra there is no single point of failure, that is it is handling the fault tolerance effectively. Cassandra is optimized for availability, although it is tunable, it is having a tunable consistency also as per the CAP theorem is concerned. Cassandra is optimized for the writes. Here the writes are lightning fast writes in the Cassandra, although reads are also very fast. And this Cassandra is easy to maintain, and also this Cassandra is infinitely scalable. That is, this is the good part of the design of Cassandra. So, all these are adding the awesomeness to the Cassandra. What problem does CQL solve? We are going to see further more detail that Cassandra's usability challenges is that again is of NoSQL, that is there are no joins and also no schema, and there is a big table which contains all the columns, hence there is no denormalization. So, big table, and here the tables with the millions of columns exist in this Cassandra's. Now, the CQL saves the day, that is the best practices which are interfaced to the Cassandra, and also Cassandra uses SQL like languages. Given all this, let us see the more detail of Cassandra data model. So, Cassandra data model consists of a key space. Key space is the entire database of RDBMS system, and the column family is nothing but the tables of a database management system. So, the Cassandra data model consists of key space, and then it is divided into the column families. So, column family is nothing but a table in a database, and this is the database. Then column families will have different rows. So, this is the rows of a table, and it will have different columns. So, the rows have multiple columns. So, this particular aspect which we have now seen, this key space refers to the database of RDBMS with respect to RDBMS, and column family is a reference to the table in RDBMS, and these are all called rows, and every row is having multiple columns. So, this comprises of the data model. Let us consider the row in one row of the column family. So, here the row contains the row key, and further the every column contains the name of the column, then column values or a tombstone, then time stamp and time to live. So, here the row key, column name, column values have different types, and column name has a comparator, and this particular comparator is defined in Cassandra. Row key has the partitioner. So, that means these row key will be used to store the rows onto the cluster or on different nodes, and rows can have any number of columns even in the same column families. So, that means this row can have any number of columns, it can be a millions of columns also can be there in a row, and rows can have many columns. Column values can be omitted here, and there will be the two more functions. One is called time to live, that is automatically after this time to live the data will be deleted, and there will be a tombstone, that is if the data is deleted, that particular flag will be set, it will not be immediately deleted by the system. Now, let us see the data model of Cassandra, and we will see how the write operation is being performed. So, write operation virtually has to do nothing in the Cassandra data model. So, here we can see that if there is a request to write, so it will be first go and write into the mem table, and then it will write into the commit log. So, commit log will ensure the reliability against the failures. So, that is why using this, but there is no read is required, and hence this particular write operation is very fast. This is called lightning fast read write operation is supported in the Cassandra. Here we can see also that these operations does not require any I/O, and all the operation has to be done is an I/O in a CPU bound operations is performed in the write operation. Hence this requires hence this is quite scalable. So, as we add more number of CPUs, this will automatically get scaled in linearly. As far as the read is concerned, reads are supported with several set of steps in Cassandra. So, let us see how the read is supported. Reads are not as fast as the writes, but still it is faster. So, when the read operation is invoked, first it will try to get the values from the mem table. It will first look up the mem table, and if the values are present, then it will be then read operation is done. If it is not there, then get the values from the row cache, and if it is present, then it will be done. Otherwise, if it is not in this memory or in a row cache, then it has to go and search the disk for these values. For that, it goes and checks the Bloom filter. Bloom filter is also a very fast way of indexing or basically searching whether the data is resides in which SS table. So, checking the Bloom filter is to find the appropriate SS table, and so it will now check the using Bloom filter. After that, it will go and check the key cache for the fast SS table search, and get the values from after getting get the values from SS table, and then repopulate the row cache. This is super fast column retrieval, and why? Because you know that a row may be split into different SS tables, because the slices of the rows, slices of the columns are stored in different SS tables. So, multiple SS tables need to be consulted. Therefore, sometimes if a particular row contains that column value which is required by the read operation, then it will be extremely fast read. Otherwise, it has to access more than one SS table, and all the row entries have to be now assessed. So, this way it will be possible for the fast row. So, all these scenarios interactions which we have shown here for the read operation. So, first it will go and check the mem table and row keys. If it is not there in the row keys, then it will be checking into the Bloom filter, and based on that it will go and check the row the key cache. So, key cache in turn will index into the SS table, and SS table in turn will fetch these values which are required in the read operation, get the values from the SS table and give it back to the read operation. Now, let us see about Cassandra query language to access this particular key value pair. This database Cassandra provides easy interface that is quite similar to SQL, that is called CQL. Let us go and discuss more detail of it. So, CQL is reintroduction of a schema, so that you do not have to read the code to understand the data model, meaning to say that the interface by which the users are going to access is quite familiar, and this is nothing but similar to the SQL, but internally their implementations are quite different. So, how this SQL is mapped into the internals of Cassandra, that we will discuss in more details. So, SQL creates a common language, so that the details of the data model can easily be communicated. So, SQL is the best practices the Cassandra interface and hides many messy details. So, to give a very quick overview of what kind of construct SQL provides. So, for just like we have seen in SQL, all these commands, similar commands are available in SQL that we will see in the further slides. So, remember that Cassandra finds the rows very fast, Cassandra scans the columns very fast, Cassandra does not scan through the rows. These are some of the features of the Cassandra, how it performs, how it does. So, we have to see all these particular 3 different steps in our operations. So, let us see that what are the SQL commands of Cassandra and how it is internally being mapped into the Cassandra. So, if there is a create table SQL command, that is the create table with the employee name, and name is the primary key, and age and role are the 2 other attributes. Now, let us populate this particular database having 2 tuples, one is called John, the other is called Eric. Now, as far as internal mapping of this SQL command is concerned, the entire operation. So, this particular name is a primary key. So, for the tuple for the row key, that is John, will become the row key for this particular tuple, and corresponding age and the roll number and corresponding age and role, they will be having their different details noted. So, this is the row key, and this entire row is identified using row key, and others are the column values. Similarly, Eric row key will be used as the row key, and these are all column values. Now, these rows are partitioned in Cassandra. So, these rows are now replicated and stored in the cluster having the row keys, and they are being accessed very fast. So, as far as this particular important point which was there, that Cassandra finds the rows very fast. Why? Because the row keys, they are partitioned across they are partitioned on the row keys, hence they are very fast to access. Now, the next example which we will see about SQL is that we have added one more attribute that is called company, and now the primary key is now the composite key. Now let us see the table or a column family which will look like in this manner, and it has two of there are two tuples with the OSC company name, and there are 3 tuples with RKG company name. Let us see that 5 different tuples will be converted into 2 different row keys. So, the first row key is OSC, and the name is the Eric, and so OSC has 2 different Eric names. So, both are over here in that same row key which is having the value OSC. Similarly, it has the age values, column values, those values are also added. So, this becomes a row key. Similarly, RKG will be the another row key, and this will have this name Anya and Ben and Chad. Their age and role, their values or column values are now put into the different column values. So, so this will be partitioned across using the row key and will be stored into the Cassandra. So, this is the sequel to the Cassandra internal mapping. Similarly, we can extend it into the more complicated example wherein the primary key is now another a composite of 4 different keys AB and then CD. So, AB is one of the primary key, and then CD and their values are corresponding values are now put in this column. Similarly, for A to N. Now, let us consider about S to T. So, this is the AB, they will become the primary key, and the CD UV and their CD values are now noted down as for E value it will be now W, and for F value it will be X, and U and V, these values will come as the column attributes. So, this way the entire row key will be mapped. Now, CQL also supports the sets, lists and map. So, they are the collection semantics. So, set holds the list of unique elements. Set means the list of unique elements, and the list is nothing but an ordered, possibly repeating the elements, that is called the set, and map is the list of key value pairs. Now, uses same old Cassandra data structure. Let us see how we can declare these things, that my set is equal to set and a text, and my list is a list of integers, and my map will be the map of key value pairs. And note that these fields, that is set, list and map, cannot be the primary key. So, the primary key will be from the normal attributes, that X and Y can be the primary key. Now, there are some operations, all these operations are supported to insert into the table these values, whether it is lists or it is set or it is the map or it is the normal values. These values can be inserted into the using insert into the command of SQL. Similarly, we can update it, we can add and we can delete the values. Now, let us see about the set, how it is being mapped into the Cassandra data model. So, that means if we are given the SQL command for SQL query for create table, my table, and here we are using the set, my set is, and the primary key will be xy. So, the set will be the set of elements, here 2 sets will be given. Now, this entry is shown like this, that A will be the row key, and as far as the columns are concerned, so primary key are x and y. So, y will be the on the primary key. So, y will be for B and for C. Now, for B there are 2 different members in the set, 2 different elements in the set. So, my set with the member 1, my set with the member 2, with the member 3, 4 and 5. Now, you see this, there will be no values in this column values, and everything will be there in the column attributes. So, this will be the internal mapping of the Cassandra sets into the Cassandra details. So, another construct which is there in Cassandra is called a list. Now, let us see the example of a list. Here the elements of the list may be repeating also. So, the primary key is x and y. So, here A will be there as a row key, and the other row key will be the B, which will be there on the column. Together they will identify this particular my list values. So, my list is some arbitrary value. So, in that there will be 2 values. So, 0 0 and 0 1 will, the first value will be 1, the other value will be 2. In this way all these list values are being used here in this case. So, maps means key value store. So, key and value will be stored here in this case. Let us see this example also. So, A and B, they are the primary keys, A and B, they are the primary keys, they are stored, and from the key value pair from the map. So, key will be M and the value will be stored over here. So, therefore, in the second row A and C will be the primary key, and their key value pair, that is from my map, and for N the value will be 3, and for P the value will be 4 and it will be 5. In this way this particular map of Cassandra CQL will be stored internally. So, let us see some example of CQL. So, we can create first the key space which is named as a test with the replication factor is equal to 1. All these things we have already studied, and the partitioner is a simple strategy which is being used for replication or storing the data. And then we have created a column family that is called create table, and the name is stuff, and all these are the elements, and the primary key will be AB, and we can perform an update into it, and then we can perform the select operations, and from select all the values from the stuff which we have just defined. And furthermore we can create select using key alias, column alias from the system is schema column families, where key space name is equal to test and column family is stuff. So, we have seen that the SQL is very familiar and it's look like SQL commands, but internally it is being handled in a different manner that we have already discussed and covered. Conclusion: SQL is a reintroduction of the schema. SQL creates a common data model language. SQL is the best practices, the Cassandra interface, and SQL lets you take advantage of the data structure of the Cassandra. SQL protocol is the binary and therefore interoperable with the languages. SQL is asynchronous and fast. SQL allows possibility for prepared statements. Thank you.